The fitness industry is lying to you. Calories don't determine fat loss or fat gain. So we're going to get into what actually works. So pretty much what calories actually are is the amount of heat needed to raise the temperature of 1 liter of water by 1 degree Celsius. That's a kilocalorie, which is what we use when we refer to like food calories. And so it's measured with this device called a calorimeter, where they measure the energy required with these electrodes. They put the sample in a cup, they use the water outside of it, and they use a thermometer to gauge it. And so the first law of thermodynamics, if you haven't heard of it, is basically that energy can't be created or destroyed, it just gets transformed to another source. And so keeping that in mind, our bodies are not closed systems. So we will convert energy. For example, we will lose heat energy through our skin, or when we're digesting, even though we're burning calories to digest food, we're actually releasing heat from that as well. And if we're out in the sun, we gain heat. So calories don't really explain fat loss because we're not a closed system. We can let heat come in and out as normal. Apart from that, our cells also use chemical energy, ATP, adenosine triphosphate. If you've done any biology course, any nutrition course, you'll know that the cells don't actually use calories for energy. They use ATP. We don't use heat energy. We're warm-blooded creatures. And so fat storage is more regulated by hormones and behavior. So basically, your body will decide whether to store or burn fat. It won't be relevant to how many calories you're eating, really. So, firstly, is insulin and nutrient partitioning. So, what insulin does is it pushes glucose into your cells. So, when you eat carbs, the carbs will be digested and turn into glucose or sugar, which will then enter your bloodstream, and so you'll have high blood sugar. And high blood sugar is very, very problematic and toxic. So, your insulin will be released by the pancreas, which will then push glucose into your cells. So then the blood sugar level drops because the sugar is inside of the cells. It's not just around in the bloodstream. And this will promote fat storage when sugar is abundant. So insulin alone doesn't cause fat gain, but if you eat chronic high amounts of carbs and you have hyperinsulinemia, so high insulin, then it will then cause your fat gain. And nutrient partitioning is when your body directs nutrients. And so, for example, high intake of carbs will promote fat storage. It's an evolutionary mechanism. So if you think about in the summer, you eat excess carbs to gain fat. So then in winter, when times are tough, there's fewer food options. You still have like excess energy on your body so that you don't starve to death. And yeah, insulin will promote storage in muscle and fat, for example. So the Randall cycle is basically your body competing to use either glucose or fat for energy. And why this is important is it can't use both at the same time. And so they'll compete for oxidation with this chart here, glucose, and this is long chain fatty acids. And your body can only use one at a time. So if you have a high fatty acid availability, your glucose oxidation reduces and vice versa. And so with the modern diet, you have constant mix of both high fat and high carb processed foods, which chronically elevates both fuels, which means you can't metabolize one system. And like I mentioned before, up here, how sugar is super, super toxic, your body will opt to use glucose, meaning you have excess fat just circling around your bloodstream, which is an issue because it doesn't get oxidized into energy and it can just get stored. And so this will be, yeah, elevated blood sugar, higher insulin, increased fat storage. And so I would, like for me, all the carbs I eat is just one or two pieces of fruit a day. But if you do want to eat carbs, I would at least eat them separately. Like I eat fruit maybe a couple hours before or after a major meal with fat in it, but don't do like the balanced meal of high carbs, high fat, high protein in one meal. It's not a good idea. And so next, this is why reducing like calories doesn't help. So there's this thing called NEAT, which is non-exercise activity thermogenesis, and this is things like fidgeting, posture shifts, and subconscious movements. And what happens when you reduce your calorie intake is you do need less, like you do less fidgeting posture shift just subconsciously. So your calories out, your energy burned will actually decrease because your body is like subconsciously trying to conserve your energy. And so yeah, apart from that, you'll also fewer calories burned from digesting food. You'll have decreased leptin, decreased testosterone, increased hunger, increased stress. So it doesn't actually really work. The equation breaks, right? And if you think this is insignificant, 90% of the calories you burn in a day are resting calories. So your body's digestion, keeping your body and brain active and neat. It's like exercise and stuff only accounts for about 10%. So it's actually very, very significant. Next is thyroid and metabolic adaptation. So T3 and T4 hormones are created in the thyroid, and they are responsible for metabolism regulation, heart and muscle function, development and growth, energy and temperature. And so when you have a low intake of calories or a low intake of food, when you're like starving yourself, you basically, your T3, T4 thinks you're in starving. So it's survival during famine. So you're literally triggering the starvation state. So it will make you super, super hungry. It will make your heart rate spike to try to make you more, more designed to hunt. It will do all of these different things just to try to keep you alive because it thinks you're dying. And it's just super stressful on your body, which is not good. Next, we'll look at leptin. It's basically like the the fullness hormone. So it tells your body when you're satiated, and yeah, fat cells produce it. So when fat cells get full, leptin will be produced, and then you stop eating. And when you're dieting, your body will reduce the leptin signal, meaning you'll increase hunger, it will increase the thyroid, and it will reduce your reproductive hormones, which is just a bad health indicator. So in obesity as well, there's leptin resistance leading to like an inability to feel full, which means you just eat more and more, you have more insulin resistance and more fat storage. So again, it's not just simple as calories. Like they did this thing with mice, and this is just pre-existing leptin sensitivity. When they're resistant to leptin, they get way, way more obese than the ones who are sensitive to it, even if they're both a healthy weight. So if you have a genetic predisposition to leptin sensitivity, you're much more likely to get really, really heavy. Again, not just calories in, calories out. And yeah, in humans, you can see this chart. You can read it if you want. But basically, the more you eat, the more you produce leptin, then you start to build a tolerance over time. And then you register low leptin, thinking you're still hungry. So then you eat more, and then you trigger more, etc., etc. It's a spiral. So next is nutrient demand and satiety. So humans will seek adequate nutrients. So like protein, fat, which are the two essential macronutrients, and then vitamins, which are micronutrients. If you think your body needs carbs, your body can actually do this thing called gluconeogenesis, which is when it produces glucose in the liver in a perfect amount, which is very, very small, and it can do that through turning fat or fat or protein into carbs or into glucose. So you don't need to eat any exogenously. So if you have low nutrient processed foods, they'll drive overconsumption because even though you eat a bunch of calories, you're still hungry because you haven't got enough nutrients and your body needs nutrients. If you didn't know, there are two types of vitamins, fat soluble and water soluble. And water soluble vitamins your body can't store, so it needs to get a new dose of them every single day. And if you don't get them, you'll just keep eating. Whereas if you eat like steak and eggs, for example, even though this is cooked, it's like minimally cooked, you'll get a lot of nutrients from this, so you'll be full very quickly. And also protein increases satiety and the thermic effect. So you'll burn calories more from digesting protein and you'll be more full from eating protein. And for example, beef liver, which is a great food, you can see like all of these vitamins, the DV is daily value. You can see it on a lot of these vitamins, it's literally like multiple times the daily value. And a lot of them, it's at least more than half of the daily value. And even these, is pretty good. So just something to keep in mind. Organ meat's super, super nutrient dense. I can eat like literally this much organ meat, like a cupped handful, and I'll be full for like hours and hours. Whereas I could eat like a full 2 bags of chips and still be hungry, right? So it's about nutrient density. Again, even though the chips have way more calories, the liver has very few calories, but it's actually about the nutrient density, which is what's making me full, not the calories, right? Next, this is actually really important, sleep and light exposure. So obviously we talked about leptin being the fullness hormone. Ghrelin is the opposite, it's a hunger hormone. So before eating, high ghrelin, low leptin. After eating, low ghrelin, high leptin. Makes sense. And so if you have poor sleep, you have higher ghrelin and lower leptin, meaning you're more hungry. If you have light at night, like blue light especially, you get insulin disruption, your cortisol dysregulates, and your appetite increases. And so, yeah, when you get light, your brain will tell what time it is, and based on that, you'll be hungry or full. And when you start screwing with your body's sleep through different sleep schedules or light exposure, you end up overeating and again causing fat gain, and again this is not calories. And lastly, we have hyperpalatability of modern foods because they're very very like sugary, fatty, which is what our brain is like coded to want to taste. Liquid calories, which is the easiest to consume. Chronic random cycle upregulation, low satiety. You have really quick digestion, and you have reinforcement through dopamine from the sugar, which is just a really really bad combination. And so evolutionarily, again, you'll want to accumulate fat for winter and lean in summer. But now we're like in a permanent harvest season where we always have abundance of food, which is really problematic because then we won't, like, our body is constantly in a fat gaining phase because we weren't used to having an abundance of food. So we'll keep trying to gain and gain and gain. So that's why you need to exercise restraint if you're eating these hyperpalatable foods, which you shouldn't be eating. And just to wrap up, like fat gain really isn't a math error. It's not a lack of self-control. It's just an evolutionary survival mechanism which is malfunctioning due to modern conditions. So don't get some stupid calorie tracker. Follow this advice in the video and you should lose fat pretty quickly. Thanks for watching and I'll see you in the next one.